Merhabalar. Öncelikle herkese hoş geldiniz.
Hi, I would like to welcome you first. My name is Gökhan Çoban I am the R&D manager at Codes Innovation Department. Our presentation will be about the products and services we have produced, and we are going to provide detailed assessment about them. I would like to start with the opening, the video about the opening of our R&D center. As you see in the video, Koç Bursa is celebrating its 50th year and the opening of its R&D center. However, the Koç company was established in 1750, a 50-year-old British company manufacturing in almost 50 countries and carrying on its commercial activities in over 80 countries. It had 3 R&D center openings this year in Europe to serve Europe and the geography we are present in. Bursa plant was opened, but another innovation center was also opened in the United States and one another in China. So these are 3 innovation hubs. We have approximately 16,000 employees around the world, and Koç goes beyond being a textile company, touching many other industries. Around 4 years ago, it started its composite activities. It has its own brands and original products. I will refer to them in the coming slides. But as for the highlights, for example, the parachutes of the Apollo spaceship, the strings of the parachute were produced. We're producing strings that will enable us to go to space and come back every day. Also, we associate these digital applications with our innovations thanks to the innovation centers. COTS Turkey was established 50 years ago, and all the activities are handled from one center. And the Turkey provides operations for entire Europe.
İnovasyon Hub'da kompozit dışında devam eden
In the Innovation Hub, other than Composite, we have products. This slide provides insight in textile, non-flammable textiles. Flame Pro series have many properties, including aramide. In aramid process, we choose the right material with the right combination and coloring. We have anti-static properties as well. We are combining all these features in products which meet the demands of our customers as well as the industry. So they are determined at COTS Global, which is a pool of ideas, because there are 18,000 employees. We're talking about a culturally diversified company. So these opinions are collected in a pool, and they are scored according to their feasibility and strength, and then we create a list, and then we try to meet industrial needs based on them. Can we move on to the next slide? Also, as I stated earlier, we are not only a standard textile company, but rather one producing industrial solutions by following up the trends. Wire and cable is a category. We included this company 5 years ago to COTS, and here we provide extra strength and tensile strength. Here they owned Ultra Block is a product within these cables. The biggest purpose here is to ensure marine cabling. They block water by absorbing in fact liquid, and it increases lifespan of the cable even when there is a damage. And it is used in all ocean floor cabling as well as submarine cabling activities. This is a big industry, and together with this Gotex company, COTS has a big market share. This is a workshop area, a composite workshop area in our innovation center. This is called Synergics, and my colleague Alican will provide further detail about the mixed fiber product we offer to the industry. So this is the mattress material and supply material brought together in an excellent manner, capable of working in quick cycles. We created a prototype line as well as mass production line for them, and when you look at their capacities, you see that it adds up to tons, ranging from 100 kilos to tons based on combinations. And we have a hot press unit which can go up to thousands of tons of production. Here the testing samples are produced here, and also we conduct simulation for our production lines here so that we can predict the problems we may encounter. Also, a 100 kilonewton universal test device is used for composite materials, conducting quasi-states within our capabilities. Again, sample cuts and other activities are conducted by CNC cutting devices. We have all the necessary measurement devices, a CATIA design program, and lattice design software, as I will refer to in further slides. So in all national and international projects, we use project management tools to provide the best timing for our clients. If we look at products that will require further detail about composites, we will listen to Alican. Hi, welcome, Alican Çelteklioğlu. Thank you for coming. I know that it's a little last minute for you. Thank you very much, Gözde, Koray as well, and our student friends. Welcome. Synergex is a fiber developed for composite applications from thermoplastic. So this is combined application hybrid strings, continuous fiber, carbon, glass or basalt are mixed. The mattress materials are nylon 612 polypropylene and TEGI or more specific products. Also, there's another product group under Synergex used for functional coatings like carbon and glass. They are used as supplies in different applications. As Mr. Gökhan stated, prototypes were first developed and we conducted tests with other clients, and we carry on development activities with the same enthusiasm. Synergex hybrid string group has such a product tree which can be extended based on the demands, but the standard picture shows SDS documents or TDS products as such. The biggest advantage of using hybrid fiber in fact, being able to provide the volumes in the form of strings. When you move on to second processes, impregnation features are maximized, cycle terms are decreased, and homogeneous structures are accomplished. We are able to calculate these proportions and offer them to our customers. In order to produce them, we need to, of course, have the supplier development activities. We cannot use every material. We are trying to increase feasibility, and there are certain visuals there showing the products we have been able to produce, and they are used in fabrics, as we see in this expo, or in other different applications like grading or mating. We are able to bend these strings, add extra coating, or in fact just spin them pro forma. On the left bottom corner you see in fact products for weaving. Filament-based products were bent to use in weaving, and they were delivered to the customers. We have a sample here. You can check them after the presentation. We have pencil tubes for basalt applications, and for peak carbon fiber PEEK-based products are used in the aviation industry, as you can see in the big picture there. Here there are certain examples from applications. Carbon fiber and PPX synergics were used to produce a product. With the advantage of thermoplastics, was pre-consolidated and overmolding was applied over it. Stiffeners in harmony with the mattress material. Maybe you've listened to it in another presentation in the other hall in terms of over molding. There is another product we call lattice. This is preform. Near net shape was the focal point. This is one type of fiber placement, and this is the molded structure in the middle, and that is the test panel visual from a breeding customer. Carbon fiber and nylon 12 were mixed for braiding, and customer is testing them before using, and they shared this test panel from the braiding application. The other product group is lattice. Lattice is a name we give to preforms, near net shaped preforms. It is a two-dimensional structure. We unfold the geometry of a structure like this and create a geometry in two dimensions and pay attention to its contours and create preforms accordingly. And then they are used in molding processes to be pressed for the final form. Stamp forming, compression molding, stamp molding are all taken into consideration. They are pre-consolidated preforms when we talk about lattice. So this is two-dimensional. We press it, we make it rigid and deliver it, or if it is going to be press molded, we deliver it without it. Fiber placement process, tailored process placement is the product. There's an announcement here. This is a process where we use, in fact, strings. Coats is a strings producer, and here some functional properties are given, like sewing yarn, and we can show a case here. After presentation, we are appealing to 4 different processes: hot press, stamp forming, compression molding, and overmolding. But also we use carbon fiber roving materials, turning them to preform, and then we use these preforms in RTM or infusion applications.
İki tanesi de infüzyonla üretilmiş ürünler. Bir tanesi RTM, pardon.
2 of them were produced with infusion. We can proceed to the next slide. Here you see a short flow of the lattice product. What we need first is 3-dimensional geometrical data. We take that data, and our design engineer friend Cem helps us turn it into 2 dimensions, unfolded part, enables us to get all the contours on the 2-dimensional plane. There are load cases of the part, and then we do a fiber placement, and fiber pad design can be seen there until the fiber placement is completed, and then the smallest preform can be seen in the last picture. There are very small number of processes that can achieve it. You cannot have the same curves as you may have an untolerated results. Here we want to provide an alternative to such issues. Also, with tailored fiber placement is good in that we can use every parameter of the production, also a parameter of the design, and take the efforts to an optimized conclusion. In this example, as Alican stated, we have a three-dimensional geometry provided by the customers, and we conduct certain design activities like unfold operation or access and other drapability aspects. We form a new geometry and a fiber pad design. Standard 90, 45, 45 are not the values. We follow the outer counter of the part and create a geometry, and the fiber placement is able to tolerate the burden. In the composite production methods, you cannot have such a fiber placement, but our products are dry fiber, dry bundle. That's why we can place them as we want. That's one of the biggest advantages of tailored fiber placement. If you have any questions, we can take as well, because we have an hour for presentation, so we can move in the Q&A fashion if you like. The interpreters can't hear unless the audience uses the microphone. In fact, we evaluate it on the basis of fiber. In woven fabric, 90% of them is maybe 0, but the remaining is 90. In our case, that's not the situation. If a placement we desire is 62 degrees, it takes place in an angle of 62 degrees. If, for example, if this is the center of excellence is like this. This is a woven fabric example. If I speak about lattice, if you consider this point zero, this is a load-bearing part, and it causes, for example, a stress cluster. We place fiber to support it with such 60 degrees. That's a test plating product. There's a loop here. I can't see. You can't see the remaining, but I can tell you. This is a fiber-based placement, so we can place everything with 60 degrees or 30 degrees, 100%, wherever is required. Of course, this can be manipulated. If the design is about 90% strengthening, then we can do it and do nothing for the rest. That will provide you with weight savings. In woven fabric, you have to include the part you don't need to. In pre-pack productions or organo sheet, thermoplastic sheet production, you need a nesting stage depending on the shape of the part. This is unfold again, degrading the part to 2 dimensions, and you create cross sections based on the surface area. There's this case study we conducted together with our customer based on the figures provided by their operation. That doesn't apply to every operation. This can provide a 100% advantage, but for non-clip fabric, Ms. Gözde would know, these are the fabric types with different characteristics. In order to turn such fabrics which do not have a fault, you need to ensure some rigidity, and 60 to 70% of them are handled manually or with simple robotic moves, but there is this placement in each and every case. We can't hear the question mark from the audience as interpreters. This 60 or 90 degree thing are not about the geometry only. This may be a mounting part in its current position. The resistance comes from the fiber itself, but the real resistance or durability is about the working conditions. It's about the fault. And here we are using a software. This is a software we run together with Katya, and fiber pad design, dealer fiber placement as another software. We are using it with license. We acquired it together with the machine. The software enables you to scan a surface area completely. You can think of it as the scanning feature of AutoCAD. We can't hear the speakers properly due to the lack of microphone. We don't have to place it one way. This head has a 360 degree rotatability, so we can place -45 here and we can go to 60 here. This means in a 2 millimeter thickness, with simple calculation, you may need fiber with 90 degrees, so you are creating a structure of 4 millimeters in order to compensate for this 90. So let's say 30, 60, 90. So you have this 30 degree and continuous filament, and we can place it like 60, 70 side area specific strengthening also are other advantages. TTFB in fact is the composite adaptation of this system. This may be an S-curve or sinus way we can define the angle we like. So this is like an embroidery work. The points here are sewing points. As John stated, every production parameter is a design parameter for us. There's a good example of it. If Synergex is carbon nylon, we can sew it with aramide and give a different property in the Z direction. So we are moving in an unknown direction, but it leads to good results. That resistance increase on the direction of Z. I mean, it's not about the polymerization of plastics only, also about the resistance strength coming from the yarn too. So for us to feed and analyze too, we need to create the data package first.
Tabii ki var. Tabii ki. Bizim yani tabii ki. Yani siz biliyorsunuz hani otomat havacılığa aslında tepkiler. İşte o noktada şuna geliyoruz. Mesela bu bir havacılık ürünü karbon.
For example, this is an aviation product, carbon fiber PEEK Synergex. We all know that PEEK is used in aviation. This PEEK material can meet the properties of the finished product. So that's about the development stage in raw materials. Here we bring them in an excellent way for fast production with less waste, and we customize the design according to the customers and products. Actually, Alican mentioned about something. Lattice as a product can be seen in this dry form. So carbon fiber bundle is sewn together and placed. If we have pre-consolidation on this, part, even in a partial sense, gains certain rigidity, reaching a consolidation level. And in the second final forming, we see a shorter duration. The duration for waiting under press, for example, comes from 5 minutes to, in a pre-consolidated product, to a shorter time span. And also the energy is also decreased. I think everyone knows about the organo sheet prepared for pressing. It is used as 090 or in other form. In our semi-processed products, we can also achieve placement as we like. And based on the process types, the cycles are decreased considerably. Well, that is developed according to the customers, but as a reference, I can say 2 minutes. In 1I mold, 2I molds, there are 5I molds. Well, for mass product, there are many ongoing projects in the automotive industry currently. The cycle time desired by the automotive can be achieved with this type of production through transformation. Structural, semi-structural, says the speaker to a question we cannot hear. In automotive, when you say cosmetics, you think of fabrics, but we can make fabrics. You can just take a look at this. We can turn it into a visual object, but the latest technology wants to take our products to a structural and semi-structural state. By the way, overmolding, it is compatible with overmolding as stated by Alican, but that's not about overmolding. One-shot cure was applied to that product. That protrusion in that part is about a resin plate and then fabric, and then there was this press, and then it gained that shape.
Yani sonuçta
Cycle time'lar nedir? Son kullanıcının
So the cycle times are the procedure of the customers. We can, in fact, align our product accordingly. If it's about induction, then this can come down 1 minute. So nylon melts at 250 degrees body then in a lower degree. So this is about the method to be selected by the end user and our adaptation. The fastest cycle time have been 2 minutes so far. As Mr. Gökhan stated, we cannot hear the question.
Evet. Yanmazlıkla ilgili ben bizim özellikle şu an çalıştığımız bir müşterimiz olmadı ama yanmazlıkla ilgili çalışan bir departmanımız var.
Particular customer who asks us to do product flammability, but our department works on flammability. They have good products, but I don't have direct concrete information. But the mattress systems can get certain materials to provide flammability, non-flammability feature. Cost starts working on composites in Turkey since 2017. This customer uses essence and carbon fiber mix. We conducted an activity to provide carbon fiber lattice and glass fiber product. We have values like 137, 167. This is not thermoplastics, by the way. This is a wet molding application, resins application. Due to continuous use of fibers and choosing the direction, for example, 50% of them in direction 0, and then you see the other direction, and we were able to make a difference with the lattice application. So you don't have to increase resistance in every case. This material can be used for fixed stiffness, but decreasing the material consumption as well as operational costs decline substantially. That was one of our first design efforts. This is a second project, carbon fiber and nylon application. Here we started doing this with our fibers. The fiber and plate tests have different standards. In a carbon fiber test, you use a standard to measure the real resistance, and then you need to apply ISO standards 527 or other standards to measure the lattice. 6 to 8% carbon fiber resistance was detected, and that's within the tolerable limits most of the time. Of course, this is about the type of carbon fiber you use, changing from producer to producer.
5000-6000 megapascal.
Certain products show 5000 megapixels, but the range is 4200 to 4700 in raw materials. We don't see any decrease in modules, but resistance of course changes, as these are processed products, and these are the carbon fiber values after processing. You don't have any polymer additives here. We have sizing applied to the integrity of the structure, yarn structure, and also perform can be seen there, done by carbon fiber and nylon, and you see the material card and test data created for that. Fiber was produced for 50%. The real value measured 49.8%. We look at the void values. It was around 1%. TG of the nylon was 55, and the crystalite value was 23, around 23%. So these values, not maybe TG, but crystallity can be changed. These values are higher than the norms generally accepted, and it enabled the customer to continue with its design, and we continue our cooperation with them.
Az önce bahsetmiş olduğum bu non-creep fabric ya da tape
Non-creep fabric or tape with the use of an organa sheet.
Case study. Bu case study'de
And our application with latex can be seen here. The standard product cycle is as such. When you use lattice, on the other hand, you see these many steps. Of course, there are many repetitions, as is a 50 to 55 manual work, but we divide it into certain stacks, and they were conducted by 2 repetitions or 3 repetitions. So we shortened. That led to a lower operational cost and also material consumption, because we used the material in the parts required, and we also paid attention to the formability of the material. And here you see these geometric shapes thanks to the durability application. This is a floor material, and when we form it, we need to have shear so that the shape can be created. Also, you need certain trim operations. This is an RTM operation at the end of the day. And we, rather than using it from carbon fiber, for this trim area, we used glass fiber, choosing the cheapest possible product in areas that we can scrap. That's also another advantage. The second case study is sensor integration of codes, where we can use our own lines. There's the circuit board connection. We are creating an antenna only, but we do it together with the perform production so that we can have the sensor integration. On top you see another case study. This is a circuit board very sensitive to receiving. Here you see Magellan antenna. When you get closer, in fact, it opens or closes depending on whether you approach your hand. Here there is this conductive yarn placement, so when you touch there you can turn on and turn off. That is an advantage on the automotive industries. This will decrease the sensor requirement of the industry. That's an ongoing case study with the customer. Last but not least, lattice applications. We have this general page. On the left hand side you see the finished product. That's the first demo. In fact, this is an English producer. This is a company working for GT races, and that is a mud guard, and that was shown in the expo before. There are certain confidentiality agreements. We cannot show everything, but we can infuse a few infusion parts. You can achieve very thin or glossy sandblasting surfaces, and you can include certain flow meshes which will increase flow. Also, you may have intermediate codes thanks to the ER and the wet speed in direction Z can be accelerated. These are all the points you can select. If there is intensive fiber stack, you can create the flow in the Z direction with the sewing yarn. This is an interesting part. This is a loudspeaker component. Now we have it. This is for a speaker. This is a speaker working with a circuit board. We are not part of it, but it maximizes the spread of the audio wave designed by the customer. Without using excess fiber, we can produce it in one go. That part, in fact, is one of the best indicators of our technology. A fiber bundle led to this structure without any cuts. It consists of 5 to 7 folds. We are able to place fiber without any cuts. It is able to transmit and increase audio. This technology was chosen for that reason. That's an RTMA application. There's a spiral in the middle, and then there's this outer counter following. These are our first applications. This is circuit board, for example. You also have preform structure. In this surfboard, reinforcements were needed. That's an aviation application indeed. I didn't know it. That was an aviation application, it appears. I mean, these are the products I like working on. As stated earlier, we offer a cost-effective lightweight solution for structural, semi-structural parts. We work with a certain know-how for Class A surfaces and cosmetics. There is a strong supply, but we are forcing the doors for structures going beyond that, and we want to be a part of our potential customers' futures by becoming the process partners, design partners, production partners. We are investing in our HR, in machines, in infrastructure. We are trying to learn fast and also educate ourselves. The reason why I'm saying is that we have colleagues from the production team. No one may be extracting stuff from the composite industry quickly, but when we communicate our knowledge to our staff, for example, the leader of the technical team helps us develop these processes amazingly in a collective manner. So we are partners for, in fact, in the futures of our customers. That hasn't been the case in Turkey so far, though. We generally have done it abroad. We want to take such a step in Turkey too, and we expect to receive certain conversion. Well, everything started with the first, as the video stated, but it is not going with strings. The world is changing, and we are a part of this change. Thank you very much for your attention. If you want to see our materials, we can